We are going to spend today and tomorrow focusing on the multiple choice corrections. I want all 7 of you to be able to address any and all of the AB questions that you got wrong, any and all of the BC questions you get wrong, just like all the problems. I want to get these under control. Because this is really the only time we're going to spend on the multiple choice. Today we're going to specifically focus on as many of the AB questions as we can. I have no intention of working through every AB question that any of you got wrong. That's not a good use of the time. Instead, I picked 8 to 10 that I think are really, they really say a lot, that there's a lot going on there. If I'm going over one of the questions that you got right, please don't waste your time. Don't waste your time with me. Just keep working on the corrections. My other request for those of you that like to participate, all the time, is if we're going over one that you got right, just stay, like eyes down, stay focused, keep rowing in your own direction. Don't get in our way, okay? There are very few questions where all 7 of you got them wrong. In fact, there's only one. There's only one. No, the very, very last one, which makes sense. All right, so we're doing multiple choice corrections today and tomorrow. Friday is when you all are going to take the BC practice test from the College Board. It's a 45-minute test, so it ties in nicely to like multiple choice review. Right, that's what we're doing. So the test on Friday will be good. It is not for a grade. I am thinking that it's going to be a, like, if you're here and you did it, and since I'm not allowed to look at the questions, I mean, that sounds like a quiz, right, that you guys are taking on Friday, and I'm not allowed to look at any of the questions, so I think I'm just going to have to assume that you're all getting them all right, and I'm just going to put 100 in my grade book on the quiz. I mean, is that okay?
Yeah.
That no one's going to be offended with 100 on the quiz?
No.
Now, if you find some sort of a typo in the question, maybe that gets you for like above a 100. Who knows? But I cannot look at the questions and we cannot have any conversation.
Are we going to take that in class?
You're going to take it in class on Friday. But it's great because it'll just be another opportunity to like practice. Go for it.
It was possible that that question, the AP, from the little stuff that we're doing, could it be on the AP test?
I don't work for the College Board yet. Who knows? All right, so there's that. BC practice test on Friday. Saturday is going to be free response focus time from 10 to 12:30. I know the 2 of you can't be here because, like Cracker Barrel, you know, they run a tight ship. Okay. What about the 4 of you? What's the plan for Saturday? Coming on Saturday?
Are we going to be able to work on the 3 days?
Huh?
Are we getting the 3 day on Friday, right?
You're going to get a 3-a-day on Friday. Saturday is going to be like 6 questions that you're working on over the course of 2.5 hours. Victoria is going to be here.
I want an invitation.
You want an invitation?
Invitation?
You're invited. Here, there's your invitation.
I don't know, I'll have to see.
Okay.
I might have to leave early, but I can check.
Okay.
What time?
Chipman? Be there. Saturday from 10 to 12:30.
You just said not. You just said no.
You said no? Okay. You nodded? Or you said, yes, I'm going to be there. Good job, Anthony. I figured you'd get there. All right. Let's talk about the grades. On the 3-a-day assignments, I am not grading them and putting a grade in the grade book right now. That is not the right thing for me to be doing. I want you to disconnect from grade mode and focus on learning experience mode. I am asking you to keep track of the number of points you earn on each question. And I'm recording that in my Excel document. My thought is this. I'm going to look at all the series questions and I'm going to say, how many points did you earn? And then I am going to take that in mind, keep that in mind when I figure out your final exam grade. Because, right, I think what I told you guys on the sheet is if you get like a 3 on the BC, like the exam grade's an 80 or something along those lines. It is going to be higher than that based on how you're doing on these 3-a-day sessions. So every one that you do really well on boosts the grade on the exam. This is a good thing. Okay. And the last thing is, last night the Winchester brothers and I in Supernatural were working through the 3 questions that you're going to do tonight. I am either not getting enough sleep or these are just some really, really hard questions. So I want you to just get yourself into your happy place and realize that these 3 questions, all 3 of them, are really tricky questions. And that's a good thing. Okay? Because we're not worried about the grade, we're worried about the learning experience. We're worried about getting ready for anything and everything they could throw at you. Trust me, I did an exceptional job choosing these 3. There will be parts that you know exactly what to do with. I think number 2 is going to be a butt whooper from start to finish. There are very few kind points in there, but do the best you can. Okay, we'll definitely talk about it. Roger, you look at a question. You're good? All right, so with all of that said, all right, first question I'm going to go over is multiple choice question number 2. My goal is for us to get through about 8 of these questions. We're going to go fast. 43% means that 4 of the 7 of you are with me right now because you got this one wrong. Where are the 4? Brian? Anthony? Maybe it's Chepe? Okay. All of the corrections need to happen on that correction sheet that I turned into you. I'm looking for 2 things to happen with your corrections. I'm going to take this just for a second. Okay? Yeah, this thing. Number 1, what's the question number? Number 2, like redo the work over here. But the most important thing is what is the key to solving this question? Like, what was the thing you forgot? Was it a formula? Was it a property? Was it, I don't know, I just didn't use the chain rule appropriately? Because the thought is that next Wednesday night, when you're all at home alone studying, you're going to be able to look at this one more time and be like, hey, what are some of the big mistakes I made on that benchmark exam? This is where you're going to look. All right. So number 2, we got y squared minus 2x squared y equals 8. Find dy dx. In the business, we would call this an implicit differentiation question. Implicit differentiation because the x's and the y's are getting mixed in together on the same side. Explicit is when you have like y equals blank. Okay? They want me to find dy dx, so I just need to take a derivative. Derivative skills are good for us. What's the derivative of y squared? The derivative of y squared is 2y, and it's some more than that though.
dy
Times dy dx. The reason for the dy dx, that's your chain rule coming in now. Right? Y depends on x. We're measuring how y changes with respect to x. So 2y dy dx. Now here's where you're going to be careful. Minus the derivative of 2x squared y. I was talking about a problem like this in the 2-day session after school yesterday. Options for finding the derivative here. 2x squared y. You could use the product rule for sure. Somebody even said, I need the extended product rule. Surprised me that anyone even thought about extended product rule. I think why they're thinking extended is that they're thinking about the 2 and the x squared and the y, and all 3 are being multiplied together. But a better thing to do here is just to say, well,
2.
right, like 2x squared,
And then y.
and then the y. This minus sign is going to be really tricky because it's minus everything, so I'm going to use the brackets there. Yeah.
Could we just do plus, like equal it and then like add it to both sides?
Oh, like move the negative 2x squared y to the other side so it becomes addition?
Yes.
Love that. Never thought about doing that. Like, never in my life I thought about doing that. Nice job. But I'm going to do minus with the brackets. We're okay? Okay. Product rule says take the derivative of the first. Well, that's just 4x. Leave the second alone. Plus, now leave the first alone. And I need the derivative of y.
1. No, wait, dy dx.
This is where you want to be careful, right? 1 dy dx equals the derivative of 8.
0.
0. For the folks that missed this one, what were the mistakes that are happening?
I just didn't know it was the implicit differentiation.
Okay. But looking at this now, do you see it? And here's the thing. they're not gonna ask you what type of question is this. Like the calculus teachers need to know how to classify, but were you taking the derivative correctly? That's good. Okay. All right, so if we want to finish this off, I want to solve for dy dx, so I'm going to clean this up a little bit. Minus 4xy minus 2x squared dy dx equals 0. Now, for the 4 folks that are with me using your super brain powers here for algebra, I need to solve for dy dx. Let's see how many moves we can combine. Mostly algebra here. What are we going to do?
Take out the dy dx.
I've got 2 terms over here that have a dy dx, so that's a common factor. Other things that need to happen.
Move x to one side.
Wait, move what to what?
X.
Mm-mm. You're trying to solve for dy dx.
You get dy dx on its own.
You want to get any term that has a dy dx on its own, which is this first one and the last one. But the middle term doesn't have a dy dx in it.
So add it.
So you add it onto the other side, so that these 2 that are left, bless you, on the left-hand side have the dy dx. And then you factor out the dy dx. And then you divide by all this stuff. Okay, so what we said is we're going to add 4xy to the other side. I've got dy dx that I can factor out, so that's 2y minus 2x squared equals 4xy. And then we're going to divide, so we've got 4xy over 2y minus 2x squared. Is the answer there somewhere?
You can factor out a 2 from the.
Yeah. There's a 2 in the numerator that I can cancel with the 2 that I can factor from the denominator. Right, and here's the mean part. On the free response, we wouldn't do that. We'd stop. Right, this is just now a matter of they're hiding the answer from you. And so you're going to get 2xy over y minus x squared.
Did you use?
Done,
Did you
done.
just use position?
You okay?
Do you want us to write like the correct answer, like it's letter B or letter?
I care less about that. I care more about you're getting the right work on there and you're identifying for yourself what was the mistake. All right, new question for us to talk about. I had to go far. Oh, I had to go far. Number 14.
Supposed to be.
Oh,
Yeah.
I got that.
Number 14, only 2 people got this one right. Either because they knew exactly what they were doing or their smarticle particles helped them guess wisely. I only want to talk to the 5 of you that got this one wrong.
Today's just A/B corrections, right?
What?
Today is just A/B.
Today we're going to focus on the A-B corrections, but if you don't have a lot of A-B corrections and you get to the B-C corrections, keep going. You can go in order, but we're only focusing on A-B corrections right now. All right, so we're the 5 folks that are with me on this one. 1, 2, 3, 4, 5. Okay, Lucio and Jeppe on your own. Good, you gotta talk to the camera. All right, graph of y plus fx in the closed interval is shown above. Which of the following could be the graph of y prime? What are the thoughts that are out there? What do we try?
Well, at first I looked like at the relative minimum, so like I knew there would be a red flag in there.
Okay, so you've got a relative minimum over here, and I don't really know exactly where that relative minimum is, but I know that I have a relative minimum. So what are you looking for in f prime?
There's a 0, but it changes from negative to positive.
Right? It's not just that f prime is equal to 0, but more importantly, f prime is 0, and there's a change from negative to positive. Does that help? Does that help either get rid of an answer?
A, B,
Right, if I'm looking at f prime,
A, B, and E.
can't be A, can't be B, and E, you want to get rid of E?
Because there isn't 2 rather than
Okay, there's only one relative extrema here. Clearly I would have 2, so it's not going to be E. It's either C or D.
Oh,
Okay. What else? What else do we know?
that At the beginning, at the end, it looks like it's gonna have two relative extrema there.
It looks like we're getting ready for two relative extrema here. And this is where I'd want to be careful about that. It looks like it's getting ready to have an extrema. I wouldn't really call it an extrema unless I see the change from increasing to decreasing or decreasing to increasing. So I don't necessarily see that happen, but what else do we know here? Let's see, I know that F is decreasing here and increasing here, so I'm looking for F prime to be positive and then negative. Whoa.
Negative then.
Negative then positive, sorry. They both do that.
Does it change in cavity in those? Or?
Is there a change in concavity? Is there a change in concavity? I think there's a point of inflection here and a point of inflection about here, right? I can't tell you exactly where those are, but if I think about the bending, I'm concave down, now I'm concave up, now I'm concave down. So what does F prime do? If I'm concave down, F prime? Decrease. F prime when I'm concave up. Increasing. F prime when I'm concave down. Decreasing, right? So I need decreasing, increasing, decreasing. Has to be D, right? Roger, you're also it's a really astute observation that it looks like we're getting a horizontal tangent line, and that is going to help. That definitely would tell me don't pick this one, right? Because I'd expect to be getting closer to zero, but I won't see the change from positive to negative or negative to positive. You good? All right, let's keep going. So that's 14. 60% of the multiple choice questions are A-B questions. Oh, here's the one. Oh, sad panda. Now, let's be real and forgiving with ourselves here. As smart as the 7 of you are, question number 23 out of 28 in a 55-minute exam block, you might not actually get there. Or you might be getting there and you are so freaked out and panicked and you just know that the time is ticking, right? This is probably what was happening. So now we get to look at this with fresh eyes. Have a conversation with somebody near you. What should you have done? What's the key here?
This is the second fundamental thing.
All I did was
You did a lot.
So square root of x squared, it's gonna start with the
You
first
know what's the
function,
second fundamental
which is
thing?
like, that's the g of x,
You know what second?
times g prime of x.
oh, this like how many equations?
So your f of x is
So the
square root of
first
x. So f of x squared, so square root of x squared is x.
So what I heard pretty much from everybody is you know you're taking the derivative of the integral of a function from a constant up to some stuff. For those of you that like names, you know the name of this theorem.
Second fundamental
It's
thing.
the second fundamental theorem of calculus. Good news, they're not ever, as far as from what I've ever seen, going to ask you to name the theorems. But you do need to know that we're taking the derivative of the integral of a function from a constant up to a thing, not a variable, but like another function. And so what happens with the second fundamental theorem of calculus, these guys kind of cancel out. Kind of, but not 100%. Right, derivative of the integral of a function from a constant up to some stuff, you're going to get the square root of x squared times 2x. So which answer?
Where did the 2x come from?
D.
Where did the 2x? Because that's what the extended second fundamental theorem of calculus says. When you look it up in your survival guide, you're gonna see it because you're not going to a variable, you're going to a function. You replace the variable with the new function, and then you multiply by the derivative. It's that, like, it looks like chain rule, but it's not. All right, so what's the right answer?
Yeah.
Should be D. Now, why D?
The squared and the square root cancel out, so you
And this is where I want you to be really careful. The square root and the square don't always cancel out. There is a reason why it's legal to cancel out the square and the square root. Because what?
It's positive.
What's the it? X squared is positive, but x squared is always positive or zero.
X is positive.
X is positive. X is some positive number. If I take any positive number and square it, and then take the square root, what happens? Those will cancel out, and now you've got x times 2x, which is 2x squared. But if x had been some negative number, imagine like -4,
not close.
-4 squared is 16, squared is 16 is positive 4, you wouldn't be able to do this cancellation, so be careful. Okay. Probably the mistake is, I just forgot about the second fundamental theorem of calculus. So that already like puts a little flag in my head that next week when I'm studying for the final, I'm gonna look over that one more time. Oh, 25.
When you get it right.
All right, 25. That means 3 out of 7 get this right.
25.
Question number 25.
Yeah.
It's 43% right. So where are the 4 folks that are with me in this one? I got one over here.
Yeah, I got it right, but I think I guessed. I don't remember.
Okay, and if you get it right by guessing, stay with me so we can be part of the conversation. Okay, I want options here.
Well, I thought it was just a derivative of a point.
Okay, you just thought it was the
Of a value.
derivative of a point, which led you to think 0. Okay, what else?
I just plugged in.
You just plugged in, and what happened when you plugged in?
Sine of pi over 3 minus, so 0 over 0.
So you get sine of pi over 3 minus the sine of pi over 3 over 0, which is 0 over 0, and how do you feel about that?
Not good, so I decided to do L'Hopital. And then
Okay, but hold on. This is the indeterminate form, and because you have an indeterminate form, that's going to get me to start thinking about L'Hopital. This is a way to go about solving this problem.
The hospital.
It's a way. So you're going to say, oh, let me take the limit as h approaches 0. We'll take the derivative. What's the derivative here? Sine of pi over 3 plus h. H is your variable. So this is cosine of pi over 3 plus h.
Times 0.
Times 1, sure, because the derivative of h is going to be 1. Minus the derivative of sine pi over 3.
0 because
The constant.
you don't have,
Right? Pi over 3 is a constant. Sine of pi over 3 has to be a constant. Derivative of constant going to be 0. In the denominator? 1. Now take the limit as h approaches 0. And what you're going to get is what? Cosine pi over 3? Which should be 1/2.
Well, I had the right thing, but I got the wrong number.
So did you evaluate cosine of pi over 3 badly?
Yeah,
Okay.
I put 0.
Okay. Other thing, I want to come back to what you said. You said you saw this as what?
it's like a constant. So.
Oh.
Yeah.
Okay. This is derivative. We have not actually found derivative or spoken about derivative in this way since like August. Way back in the day. Way back before derivative rules. There was a way that we used to find derivatives. Way back in the day.
Rate of change.
You'd find rate of change, but specifically it looked something like this. It was the limit as x approaches a, f of x minus f of a over x minus a. And then we also would look and say, oh, limit as h approaches 0, f of x plus h minus f of x all over h. both of those mean derivative. That's what you're doing over here. But specifically, what's the function? What's the function that we're taking the derivative of? Sine, and you're finding the derivative at pi over 3. So you find the derivative of sine, which is cosine, and you evaluate pi over 3. Hey, that's exactly what we did. All right, we've only got 5 minutes. I'm going to choose wisely here. 27 involves derivatives of inverses. You can look that up in your survival guide. Number 30, maybe number 30. Oh, okay. Let's do 30 and 44. And I think we're going to call it a day, 30 and 44. Okay, 30 and 44. 30 is really 77.
30?
Oh, yeah, this one, I forgot how to do that.
Yeah, okay, so 30 is really 77. All right, we've got two differentiable functions, f and g, shown above. The function p is defined by p equals f of x times g of x. Which of the following must be true about p prime, the derivative of p? So for the folks that get this wrong, what did you try? What did you think when you saw this?
Try to see what p prime of x is like in general terms.
Okay, so tell me about p prime of x in general terms.
Use the product rule. I tried to do the product rule.
Great, you will use the product rule, so what does the product rule tell you here?
F prime of x times g of x
F prime of x times g of x
plus f of x g prime.
plus f of x g prime. Love it. Love it. Great. So which of the following is true? Oh, look at this. P prime at -2. Well, let's figure out P prime at -2. P prime -2 says find F prime of -2 times G of -2 plus F of -2 times G prime of -2. F prime of -2 means go over to the graph of F, evaluate F, the derivative of F at -2. What's the thing you know for sure about the derivative?
Will be positive.
Positive. Who are the folks that missed this one? Oh, so it's 3 of you, so I'm going to stop looking over here. Hello, friends. Okay, so Anthony, you're saying F prime of -2 is positive. Why? You're right, but tell me why.
The function is increasing.
The function F is increasing at this point, so F prime must be
Positive.
positive. Great. So I've got some positive number. Now, positive what? I don't know. Don't know. What about G of -2, Nathan? What do we know about G of -2? Is there anything you know for sure about G at -2?
It's negative.
It's negative. Negative what? Don't know. Yeah.
Could we say it's 0?
Could you say it's 0?
Oh wait, no. Like no, I'm saying the derivative of that point would it be 0?
Well, we're going to need that information eventually, right?
Yeah.
So F of -2, I go to F. What's F of -2? Oh, 0. Honestly, I wouldn't even do anything else. Right? Why bother going over and saying what's G prime of -2? G prime of -2 is 0. Great. What I care about is I already know negative. So A should be the right answer?
Wait.
Or did we make a mistake with the derivative here? F prime of -2 is positive. G at -2 is some negative number. F at -2 is 0.
Oh, it would be 0. It would be
G
A.
prime of -2 is 0. So yeah, so it's
A.
A. Other thing they could have done, they could have said, tell me about the behavior of P at this point. What's the behavior of P? If P prime of -2 is less than 0, then P is
Decrease.
decreasing at x equals -2. All right, last one. What did I say, 44? 44. Okay. Yeah, not a surprise that this one went oh so badly. All right, at this point, you're running out of time.
Yep.
We are running out of time here in class. This is the second to last question. We have to talk about number 45 tomorrow. Somebody please remind me, because none of y'all get number 45 right. These are rare when it happens. Let's do 44 quick. A container has shape of an open right circular cone as shown in the figure above. The container has a radius of 4 feet at the top. Radius 4 feet at the top. And the height is 12 feet, okay? H is 12. Water flows into the container at a constant rate of 6 cubic feet per minute. What the heck is that?
dr.
6 cubic feet per minute. There's a clue here. This is dV dt equals 6 cubic feet per minute. How fast is the water level rising when the height of the water is 5 feet? So when h equals 5, what is dH dt? You know that the volume is 1/3 pi r squared h. I need dV dt. So we need a derivative. The derivative of 1/3 pi r squared h.
1/3 pi r squared dH dt.
Okay, I'm gonna leave that 1/3 pi out because that 1/3 pi is the constant, right? That's easy. Now it's just a matter of what's the derivative of r squared times h.
Oh wait, 2.
So product rule. So 2r dr dt times h plus leave r squared alone times dH dt. Okay, we're almost done. Things that we know for sure. We know that the radius up here is 4 feet, and we know that the height is 12 feet. The mistake, though, is going to be to use the 4 and the 12 right now. Right, because they want to know what is dH dt at h equals 5. So you've got to consider this whole situation at h equals 5. Well, what's dV dt at h equals 5?
6.
How do you know that?
Says it right there.
Okay, the important thing though,
It tells you.
it tells you, sure. But how about the fact that it's a constant rate? The rate isn't changing. So at this moment in time, dV dt is equal to 6. We've got 1/3 pi. 2 times, what's the radius?
4.
Come on in.
4.
And this is where the mistake gets made.
Dimensional number.
The radius is not 4.
Oh, so it's.
There is a time when the radius is 4. This is not the time. What we had to do, what we were doing before, is we'd look at, we'd say, okay, well, there's some time where the height is equal to 5. What's the radius there? And you would look at these two triangles and do a little proportional work. I don't want to go any further. We're already over time. Tomorrow, I definitely want us to talk about 44 and 45 for the beginning. Okay. All right. So 3 a day, day 3 tonight is